Hello, future engineers, subscribers, viewers, and students. Here is another video in VITAMATH 97, particularly on the topic plane geometry. I hope that you will be able to follow the presented 5 solutions here and recall the important concepts, principles in plane geometry so that you will be able to understand and increase your thinking skills, particularly on math problems, which will mold you to become better engineering students. Here is the problem. The circle has its center at C. Angle ABC measures 15 degrees and angle ADC measures 55 degrees. Find angle AOC. So here is the given figure. So if you look at the figure, we're looking for angle AOC, and I will call it theta in the figure. So first, I'll extend this radius here, DC, and because that's another way of solving the angle theta AOC as shown in the figure. So we use the principle here that for peripheral angles such as this angle here, 15 degrees, if extended, then the central angle measures double this corresponding peripheral angle or inscribed angle. So if we draw a line from the center extending this radius, that radius and this another radius, which is the same arc subtended by this 15 degrees, imagine this arc here, the angle occupied by this arc is equal to double this angle 15 degrees here. So that's the idea. But the first solution, we consider triangle AOC, AOC, but we need the measure of this angle here, because triangle ABC is isosceles. Take note, this is the radius, BC is also the radius, AC is the radius, so we conclude that triangle CAB is isosceles. So therefore, the measure of this angle here is also 15 degrees as shown in the figure. So if that is 15 degrees, we also note that in triangle ACD, which is also an isosceles triangle, AC is the radius, CD is another radius. If the measure of this angle here is 55 degrees, which is opposite to the radius, this angle here, the measure of this angle here, which is opposite to radius CD, is also equal to 55 degrees as shown in the figure. So therefore, since the sum of the interior angles of a triangle is 180 degrees, angle ACD is equal to 180 degrees minus 55 degrees minus 55 degrees. Since 55 plus 55 is 110 degrees, so angle ACD is 70 degrees as shown in the figure. So having found angle ACD as 70 degrees, we then consider triangle AOC, and take note that the sum of the interior angles of triangle is 180 degrees. So in triangle AOC, theta, the first way, this is the first way, theta is equal to 180 degrees minus 15 degrees minus 70 degrees. So theta equals 180 degrees minus 15 degrees minus 70 degrees. So theta is equal to 95 degrees. So that's it. So therefore, this angle here, angle BCO or BCD, is this angle here. After we consider this triangle, So in triangle BOC, we need to compute another angle. This is 180 degrees minus theta, of course. And this angle here is 80 degrees because angle ACB, angle ACB is the sum of the interior angles is 150 degrees. 180 degrees minus 15 degrees minus 15 degrees is equal to 150 degrees. So that's angle ACB. But since we already found 70 degrees here, so therefore this angle BCD, is equal to 150 degrees minus 70 degrees. Again, angle ACB or BCA is 180 degrees minus 15 degrees minus 15 degrees. Since we already found 70 degrees here, therefore this angle BCD is 150 degrees minus 70 degrees. That's why it is 80 degrees. Therefore, considering triangle BCO, this is 180 degrees minus theta, 180 degrees, straight line angle minus theta. So the sum of the interior angles is 180 degrees. So that is 15 degrees plus 80 degrees plus 180 degrees minus theta is equal to 180 degrees. So solving for theta, cancel out 180 degrees, negative theta to the right. So theta is 15 plus 80. So it is equal to 95 degrees. The third way of solving for angle theta is that the measure of this angle, this total angle here, because this is already 70 degrees. So this is a straight line angle, 180 minus 70. So this angle is 110 degrees. 180 minus 70 degrees. So that is 110 degrees. So if that is 110 degrees, the measure of this angle should be 110 degrees minus 90 degrees, because this is vertical horizontal, so that's 90 degrees. 110 degrees minus 90 degrees, so that's why that's 20 degrees. Another way is, because that's 70 degrees, this is also 70 degrees, that angle there is 90 minus 70, so that's why I indicated there 20 degrees. Take note that theta is equal to the average of the angle occupied by the subtended arcs. So that's why I extended this chord earlier, and this is the other chord AB. Then there are two arcs subtended by the chords. So those arcs are this arc here, and the angle occupied by this arc is, of course, obviously equal to 110 degrees. That's the central angle. Again, this arc here occupies an angle equal to 110 degrees. The other arc subtended by the chords AB, and this chord here, which I extend, is 80 degrees. This is the other arc. This is the other arc, and the measure of this arc, or the angle occupied by this arc, is already known, 80 degrees. So theta is also the average of the angles subtended by its arcs. So angles occupied by the subtended arcs. So this is 80 degrees, and that is 110 degrees. So this is the principle. Those are the chords, and that's theta. So these are the radii, and this is the corresponding central angle, which is, I'll call it beta 1, and that beta 1 is the angle occupied by the subtended arcs as shown, the orange arc. Likewise, the other arc subtended, so that's beta 1, that's also theta, and this angle here is beta 2, which is equal to the arc, the orange arc below, and it occupies an angle equal to beta 2. which is also this angle occupied by this arc beta 2. So theta is simply the average of beta 1 and beta 2. So 1/2 of quantity, in this case, 110 degrees plus 80 degrees. So that's also 180 degrees. So theta, average of the subtended arcs, 110 degrees plus 80 degrees. Average of the angles occupied by the subtended arcs. Beta 1, which is in this case 110 degrees, then beta 2, which is in this case 80 degrees. So that's why it is also 95 degrees. So for the third way of determining the angle theta, so we consider next triangle AOD, which is in this case, this is 180 degrees minus theta as shown. And this angle is 55 degrees minus 15 degrees, so that's 40 degrees. And this angle here is 180 degrees minus theta. So considering triangle AOD, the sum of the interior angles is 180 degrees. So from the figure, 55 degrees plus 40 degrees plus quantity 180 degrees minus theta equals 180 degrees. Cancel out 180 degrees, transpose negative theta to the right, so theta equals 55 plus 40 degrees, so that's why it is 95 degrees. Then next, fifth solution. The fifth solution, applying this principle here, the chords also subtends arcs AD and this arc here. So since this is 110 degrees, this is 70 degrees, and this angle here, which is subtended, this arc here, which is subtended by this 15-degree angle, you look at it, extend, so that's 15 degrees. So therefore, this angle here is 2 times 15 degrees, 30 degrees. Another way of computing that this is 30 degrees is 180 degrees minus 70 degrees minus 80 degrees. So that's why this is really 30 degrees. So that's 70 degrees equal to this, and this angle is 30 degrees. So likewise, this chords also subtends this arc, which is equal to, the angle occupied is equal to 70 plus 30, 100 degrees. And this arc here, AD, which is equal to 70 degrees. Therefore, by this principle here, theta is also 1/2 of quantity 100 degrees, or in 180 degrees minus theta rather. This is the angle, and it subtends these two arcs. So one arc is AD, for example, is occupying an angle of 70 degrees, so 1/2 of quantity 70 degrees, while this arc here, the angle occupied by this arc is 100 degrees, 70 plus 30. So 1/2 of quantity 70 plus 30, 100 degrees. So 70 degrees plus 100 degrees. Average of that is equal to this angle here, angle between the chords, 180 degrees minus theta. So theta is 180 minus, this is 85. This is 85 degrees. So 180 minus 85 is 95 degrees. And the final way of computing the angle is we consider triangle BOD, because this is also theta. That's also theta. This is 35 degrees. The reason why this is 35 degrees, it's because we already found 40 degrees and this is 55 degrees. This is equal to 50 degrees, supposedly 50 degrees. That's why this must be, the sum of this angle should be 50 degrees or 35 degrees. This is 50 degrees. Triangle BCD is an isosceles triangle. This is 50 degrees. This must also be 50 degrees. That's why 35 minus 15 is 50 degrees minus 15 degrees is 35 degrees. Another way of explaining that this is 35 degrees, because this is a peripheral angle subtending arc AD. And this arc AD is occupying an angle equal to 70 degrees. Remember the principle. So therefore, this angle is 1/2 of 70 degrees. 1/2 of 70 degrees is 35 degrees. So that's why I showed here 35 degrees. This must be 50 degrees because triangle BCD is isosceles. 15 plus 35 is 50. So that must also be 50 degrees. And therefore, this is equal to theta as shown in the figure. And in triangle BOD, the sum of the interior angles is 180. So in triangle BOD, theta is 180 degrees minus 35 minus 50. So theta equals also 95 degrees. So that's it for this video. If you can find another way of computing theta, then try to continue solving this problem. But I think I already filled all the angles here. So that's why, for me, these 6 ways of finding theta are enough.